Hello and welcome everyone. Thank you so much for joining us today. We're thrilled to have you here for our webinar on OWASP Top 10 2025, Understanding and Mitigating Modern Web Application Risks. My name is Ishana Dubey and I'll be your host for today's session. Before we dive in, let me give you a brief overview of what we'll cover in today's webinar. Introduction to OWASP, what it is and why it's trusted globally. OWASP Top 10 Overviews Understanding the 2025 Release Candidate. Deep diving into key categories like broken access control, software supply chain failures, and mishandling of exceptional conditions. Comparing 2021 module versus 2025 module, like what's new, removed, or consolidated. Practical implementation, such as applying OWASP into top 10 in your organization. We are honored to have Satyam and Divyanshi with us today. We are excited to hear their insights on this topic. Before we get started, a few quick housekeeping items. Please ensure your audio is muted during the presentation to minimize the background noise. We'll have a Q&A session in the end of the webinar, but also feel free to submit your questions to the chat box at any time. We'll address as many as we can. We encourage you to engage with us throughout the webinar. Feel free to share your thoughts and insights. Without further delay, let's get started. I am excited to turn it over to Satyam, who will lead us through today's topic. Satyam, over to you.
Thank you, ma'am. Uh, Thank you for the introduction. I am excited to be here today to talk about OWASP and its role in helping us build secure web applications. I will start by giving you an overview of OWASP and its ecosystem, and then my friend Divyanshi will take over to dive deeper into the top 10 security risks and how we can protect against them. So, moving forward, let's start with an introduction to OWASP and why it's so important in today's web security landscape. OWASP stands for Open Web Application Security Project. It's a global non-profit organization dedicated to making software security better for everyone. What makes OWASP so valuable is that everything they create, whether it's guidelines, tools, resources, is completely free and open and also community driven. Experts from all over the world contribute, which means the guidance is practical and reliable and also unbiased. Because of this, organizations, developers, and even government regulators often rely on OWASP as a trusted foundation for web security best practices. In short, OWASP helps us understand the biggest security risks in modern web applications and provides the tools, knowledges to protect against them effectively. Today, I will be talking about the OWASP Top 10, which highlights the most critical security risks for web applications. Understanding these is a crucial step in building secure software and keeping users safe. Now that we understand what OWASP is and why it matters, let's take a closer look at the OWASP ecosystem and the projects beyond the top 10. Most people know OWASP because of the top 10 list, but OWASP actually has a much bigger ecosystem. They maintain projects that cover every major area of application security, from APIs and mobile applications to cloud native environments, machine learning models, and even AI driven applications like LLM, ML. Each top 10 list is based on thousands of real world security incidents. So it is not just theory. The goal is to provide simple, actionable categories that help the community to understand what attackers are doing today. This FIRE ecosystem allows organizations to take a holistic approach to security, protecting not just websites. It's not just about the websites, but all the platforms and technologies they build on. With that foundation, let's see what's new in the OWASP top 10 for web 2025, which reflects the latest trend and risk. Before that, in my screen, you can see OWASP top 10 for web application that depicts the top 10 reports for web application in the OWASP. And there is a mobile application OWASP top 10, and even for API that focus on the most common and impactful security risk in API driven applications. And also OWASP top 10 for LLM that spotlights the main security and misuse threats in large language models and AI applications. The last one, not the last one, but the one that we mentioned, OWASP Top 10 for ML, that identifies the key risks and attack vectors in machine learning and system and models. So moving forward, I am going to handle over to my friend Divyanshi here to discuss about the OWASP Top 10 Web 2025. So
Thank you, Satya. Hello, everybody. This is Divyanshi. Now, let's move into the core topic, which is OWASP Top 10 Web Application 2025. It is the release candidate stage. What does that mean? Like, it is the version, like nearly final version on global data, community feedback, and threat research. This update reflects how the modern web landscape has evolved, especially with cloud native application, supply chain dependencies, and more complex architecture. Let me walk you through the top 10 categories in the 2025 list. First one, broken access control. Second, security misconfiguration. Our third category is software supply chain failures. It is the new category which is added in the OWASP top 10. Fourth one, cryptographic failures. And our fifth one is injection. Sixth, insecure design. Seventh one is the authentication failure. It is the rename. This category is renamed in the OWASP list. Eighth one is software or data integrity failures. Ninth one, logging and alerting failures. It is also renamed. Our last is 10th, mishandling of exceptional condition. This category is also new. So this is the short overview of the OWASP top 10. Now let's move ahead and deep dive into the each category of the OWASP top 10. That's one, broken access control. So this is the like it is the still at the top this broken access control, so it is holding the position 1 in the 2025 OWASP top 10 list. So despite year of awareness, broken access control remains the most exploited category in real world attacks. This happens when a user is able to perform actions outside their intended permissions, essentially breaking the rules that defines when should and shouldn't allowed to do. So in 2025 edition, OWASP also has merged the SSRF category, recognizing that many SSRF flaws system from improper access restriction at the server or the resource level. So some typical issues under broken access control include like role or privilege enforcement flaws, which means like when user can escalate permission simply by manipulating the request. Our second one is the IDOR, insecure direct object reference. It is the full form of that IDOR, where sensitive data becomes the accessible just by modifying URL or the parameter which is present in the URL. So next is, and as mentioned, like SSRF is now a part of this group because of an internal resource is allowed to accept external calls. That's fundamentally an access control weakness. The impact of broken access control is extremely severe. It ranges from data exposure to privilege escalation, and in many cases, complete account or system compromise. So on the right side of the slide, you can see there is CW is mentioned. So it is related to this category only. So like for example, CWE 200 and 201, both related to the sensitive data exposure. CWE 918, which covers server-side request forgery, and CWE 352, related to the cross-site request forgery. So all these CWE represent to this category. Now, this is the depth overview, which is the broken access control. Now, that's why this is on the top of the list. So now next, moving on to the next category of this OWASP top 10. Our next category is software supply chain failure. It is the new category which is added in the OWASP top 10 list. So, supply chain failures occur when vulnerabilities or tampering in dependencies, libraries, or build pipelines compromise your application. What does that even mean? Like, whenever during the development, whenever a developer is pushing the code to the CI/CD pipeline and it is automated and it is not secure. Third-party libraries, they are installing the third-party library without the hash values. So you have heard of the SRI, sub-resource integrity. So it is basically what I'm saying. So software delivery and update process. Whenever the new update is come in the market and we just download it without even seeing that it is secure or not. So basically, this is the software supply chain means. So let me see give you the real world examples for that. Our first one example is malicious or backdoor code inside open source package. And the second one is the compromised build server injection malware into application. The third example is unsigned or unverified updates being pushed into production. So all of this scenario which is discussed, it comes into this category. So overall, this category highlights a crucial point in 2025. Your application means securing everything that your application depends on. From here, Mr. Satyam will take it. So Mr. Satyam, over to you.
Thanks, Divyanshi, for that overview. I will continue by diving into one of the important risks in the OWASP top 10 is mishandling of exceptional conditions. The next addition to the 2025 OWASP top 10 is mishandling of exceptional condition. Mishandling of exceptional condition. So applications encounter unexpected conditions all the time. Invalid inputs, system errors, timeouts, and more. When you put something and it shows some different thing but which it should not show. So this category focuses on what happens when those conditions are not handled safely, leading to potential data exposure, crashes, or sometimes unpredictable behavior that show us some internal things of the system, of the software, of the application. On the slide, you will see the core definition. The risk occurs when application fails to manage unexpected conditions properly, which can expose sensitive information or cause system failures. Let's break down the key areas where this typically occurs. Unhandled exceptions leaking system information. So sometimes what happened is the input given by the user, the handling of that input, if the application does not have the proper answer for that, proper configuration for that, then it may show things that it should not show, leading to leaking the system information. Sometimes server version, sometimes the version, the components, the third party components used in the website. So it is like limitless. You cannot say that only server version is shown, only this shown. So it's like it's that part of information. So next is inappropriate fallback logic or unsafe default behavior, where like in some of the application and servers, there are some default information that has been stored that shows to the user in front of us. So that should not be the case. So the talking about the next error messages that reveal sensitive internal details, anything the related to credential, related to URL, related to internal sites, related to server information, related to its dependencies, its components, etc. So when these weaknesses appear in production systems, they create real world vulnerabilities, and these are very costly to handle. So some common examples, if you ask me, I will tell that stack traces being shown directly to users, where a website stack traces shows the errors, and those errors contains the internal of the websites. Sometimes even from those information, the application crashes because they can't handle unexpected input. Like for login page, what our web application will expect a user ID or password. But what if we put some strings we put some strings, some payload, some like more than 50 alphabets username. So what are the conditions that will handle those situations? So these are not defined sometimes. So sometimes what happened was people will imagine that in the web application we have to put 5-digit username. That's safe. But what is the logic behind that? What are their restrictions and all? So what are the cases when those things will be handled? So this can cause the application crashes, maybe, may not be, or some of the other dependencies regarding this, some of the other cases where it can show. So if we talk about the next, there's a silent failures that skip logging or alerts, making incidents harder to detect. So it may sound little jargon, what it is, what logging, what alert, what everything. So what happens when we log in a web application and it does not show any alert? Alert in the sense, like if there is a web application, I tried 50 wrong passwords and there is no alert on the server side, there is no alert on the organization side. I can open one account, enter a valid email and enter wrong password 20, 30, 40, 50, hundreds of times. And there are no alert. There is no monitoring. There is just logs are storing, but there is no principle set so that these things can be shown, can be alerted. So these are the major information. Maybe this vulnerability makes the place number 10, but it's not that number 10 is not impactful. It is the occurrence of that. Like number 10, it's based on the occurrence. So these things are very bad and impactful too. So if we talking about associated CWE, we see the impact, the definition, impact in the sense of information disclosure, system instability, and security gaps. So associated CWE, common weaknesses. You can see under associated CW, there is a CW209 mentioned that shows the generation of error message containing sensitive information. Sensitive information. Simply, if I have to put simple words, I will put sensitive information, simple words like that. Anything that is not in my scope to see, that is not needed to shown to the user, and it's shown. And CW, talking about CW234, that is to failure to handle missing parameters. And talking about CW274, improper handling of insufficient privileges, where a normal user try to access admin's account, admin using admin credentials, URLs, username, and all. So moving forward, CW 476, the null pointer reference. So all these CWs are being associated, mapped by the organization with these mishandling of exceptional conditions, OWASP top 10. That's why it makes position number 10. And these CW will provide that information so that you can comply, you can see what mishandling of exceptional condition has the backstory and all. Moving forward, we have discussed we have discussed the number one, broken access control. That's not the new addition, but broken access control remains at top number one. So it should be talked because it makes it position number one. And after that, my friend Divyanshi discussed about software supply chain. So that's the new addition, software supply chain failures. And she handed over me for mishandling of exceptional condition. So that's the new addition. So in total, we discussed three OWASP top 10 vulnerabilities. Then where 7 goes, they should also be discussed. They even make places in that OWASP top 10 list. So if we talk about security misconfiguration. So what is the security misconfiguration? Whenever you create an account, you put your username as admin and password as admin. If you go around, like nearly 50% of the web application has their credential as default. So that's a security misconfiguration where you use default settings, insecure cloud or testing in test deployments. Moving forward, the cryptographic failures. What is the cryptographic failures? So it's like when data flows, it should be encrypted. It's not casual that you can see my password, I can see your password. These informations are not should be clearly visible to everyone. They should be encrypted. So what encryption mechanism and what these things will follow? So cryptographic like our payment details, username, password, These things should be encrypted when they travel over the internet, travel over the networks, and reach to the servers, from server to client. So these should be encrypted to follow the best and safe standards. So that's why we talked about cryptographic failures. Talking about the next, injection. Injections means just we are putting some payloads or some malicious part of code that can impact the web application. So it is insecure design refers to system. Sorry. Injection happens when user input is not validated and gets executed as a command. Example, a login form that allows someone or type or 1 is equal to 1. So these kind of payloads to bypass the authentication. Moving forward, insecure design. Insecure design refers to systems that are not that are insecure from the very beginning. For example, a password reset page is there that does not limit how many attempts someone can make, letting attackers brute force reset codes. Like there is a web application, it has a login page where you can click on forgot password hundred of times. Like there is no restriction. And so these things make things attackers to easily do their testing, do their brute force so that they can bypass that. Now, moving forward, we will talk about authentication failure. So, what authentication failure is? These occur when identity verification processes are weak. For example, if we talk about a site that does not expire session cookies, allowing attackers to reuse an old stolen session, where a session is stored and it is not expiring. Even when the user is logged out, still the session is valid. So, if anyhow some attacker or some malicious actor will get those session cookie and the user has logged out from their account, but he is using the same session cookie. So this we can say as authentication failure. Next is software and data integrity failure. This includes using untrusted or tempered software components. Example, if we talk about the example, let's say a developer downloads a free plugin from the internet without verifying it, whether it is genuine or malicious, and it contains a malicious code. So this we can say that as software and data integrity failure. Moving forward, logging and alert failures. This happens when system fail to record or alert on suspicious activity. For example, if someone is tries to log in some user accounts, let's say xyz.com, and he's trying his password, he's tried 500 passwords, all failed logins. But the system server side, there is no alert that even if that person logged in, tried to brute force 100 times, 500 times, there is no alert. So it will cause to the alerting failures, logging in alerting failures. That's why this makes place in the OWASP list because all these seven plus those three that we discussed earlier, all these 10 will make those impacts that are going to impact the web application part and the organization, user, everybody in the supply chain. All will be impacted from these things. Moving forward, this now we want to compare the 2021 versus 2025. Let's take a moment to compare how the OWASP top 10 has evolved from 2021 to the new 2025 version. The slide highlights some of the most significant changes. First, if we talk about SSRF. In 2021, SSRF was listed as its own category, ranked number 10. But in 2025, it is no longer separate. Instead, it has been merged into broken access control, which remains the top risk. The consolidation reflects how SSRF is often an access control bypass rather than a standalone weakness. So that's the update that SSRF is combined into broken access control. Next part is supply chain. This did not appear at all in the 2025. If you look at the 2021 list, this is not there. But in 2025, it enters strongly at number 3. The addition is driven by the sharp rise in dependency related attacks, tempered packages, and CI/CD compromises. Then we have error handling. Again, this was not listed in 2021. That just got added. but in 2025 it added now. It appears as a new category at number 10, recognizing the risk caused by unhandled exceptions, unsafe fallback logic, and sensitive error messages. Finally, it's logging and monitoring. Back in 2021, it appeared as a monitoring failures, but in 2025, it evolves into logging and alerting failures with a strong focus on real-time detection and response. With the evolution of AI and automated tools, people are brute forcing the login page, bypassing the security and all. So that's why it stands and it changed its name, logging and alerting failures with a strong focus on real-time detection and response, not just collecting logs. Collecting logs, analyzing it after 1 week does not make sense, does not give the holistic security to the web application. So, not just collecting logs, but actually acting on them, logging and monitoring. So, overall, the 2025 updates reflects real-world trends, a growing supply chain, threat landscape, recognition of exception handling issues, and the need for faster alerting. These changes helps organization prioritize the most relevant risk for today's environment. So from there, I'm going to hand it over to my friend Divyanshi. To
Thank you, Satyam. Now let's moving forward. The next is the addition, removal, and renaming. In this slide, we are just going to like taking the overview. Like actually, you have already seen over the webinar, like which one is the removed and which one is the renamed. So it is the overview. Like I'm just repeating those in short. So let's wrap up by looking at overall changes introduced in the OWASP Top 10 for 2025. This slide summarizes what been added, removed, and renamed. So, starting with the what's been added. First one is the supply chain failures added due to surge in attacks targeting dependencies, libraries, and CI/CD pipeline. Actually, this is the new concept of the CI/CD pipeline and supply chain attacks, which is already ongoing. So, from 2021 to 2025, the DevOps field is increased and it's getting in the market at the boom place. So that's why this category has taken the separate place in the OWASP top 10. Now, our second category, which is added, is the mishandling of exceptional condition introduced to address risk caused by poor error and exceptional handling. As Satyam already defined you what is mishandling of exceptional conditions, so you already got the high level of overview, like what is the mishandling of exceptional errors, which is caused by due to some when the debug mode is on or the stack traces disclosure. So this is it. So now next, let me talk about like what's been removed. The SSRF, it is not removed, it is basically added into the broken access control because it is typically results from the insufficient access validation. So it is just added up to, means merged into the broken access control. And finally, what has been renamed? So like first one is the authentication failures. It means like the meaning is same, only just for the modernized to better reflect current authentication and session related risk. So and logging and alerting failures. It also renamed the basically the meaning is same of both of these OWASP top 10 vulnerabilities, but the it is only renamed to emphasize the importance of real time detection, not just log collection. So this is it. And now moving on to the next slide. Key takeaways for organization. Before we close, I want to highlight the key takeaways organization should remember from the OWASP top 10. So first, it is important to understand that the OWASP top 10 is a minimum baseline, not the full coverage. Now you're thinking of like why it is OWASP top 10, like only the top 10 vulnerabilities. There are so many vulnerabilities in the market, which is not in this list. Why only the means the number count is 10. So it is just like not the complete checklist. OWASP has defined the top 10, which is all which fall into these categories. So basically, it defines on that system. So organization should treat it as the starting point, not the complete checklist. Okay, so next our like secure by design principle, key takeaways. So the first major takeaway is adopting secure by design principle. Means what? Building security into every stage of development. Means from the starting point, from the planning and to the coding, and then onto the deployment, and then to the unit testing. All these, when an application develops, these is the initial stages where the developers start from the scratch. So basically, we have to whenever we design some any application, we have to make sure that security should be in our mind. So what it costs, like it reduces the risk, cost, and rework later. So our next key takeaway is the verified supply chain. As I already told you, like what is supply chains and what attack means. So modern application depends heavily on third-party libraries, APIs, cloud service, and open source components. Now you're seeing like nobody is deploying their own servers, physical servers in there. They are taking the help from the cloud services, installing the third-party libraries. So their application will be load balanced and it moves so fast as compared to like the 2012 or the 2010 application, and now you can see the 2025 application. Now how that time the application works, and now is what how the application works. So organization needs strong mechanism to verify the integrity and security of every dependency they use. So our next key takeaway is continuous monitoring and alerting. As Satyam is already introduced like what is monitoring and alerting system. If there is no like if you give so many inputs in the web application, like on the forgot password, you have given the so many requests, and there is no alerts in the mail or like in the IDS system, and you have no system to the to for that you will get the alert message like somebody has from the same IP address has taken the request, this many requests. So basically, it means that. So now our closing statement, like so overall, treat OWASP top 10 as the living benchmark. So moving on to the next slide, it is the conclusion. Now let's wrap up this call. So we go throughout this webinar, whatever we go learn from this webinar, I will just take a brief normal overview, like whatever we go through. First one is the OWASP top 10 for Web 2025, shows just how vast web threats and security practices are evolving. Second, this year, two major additions, software supply chain failures and mishandling of exceptional condition. So shows us how complex modern software ecosystem have become. Next one, the OWASP top 10 is a baseline, not a full checklist. As I told you previously, organizations should use OWASP guidance to strengthen defenses, educate development and security team, and stay aligned with the emerging best practices. And finally, staying current with OWASP updates, helping you remain resilient and proactive. So this is it. Thank you for attending and hope you have gained the valuable insights. Now, moving forward, the Q&A session, like the chat box is over to you. You can ask the question, whatever in your mind, and we will give you the answer. So if you have curiosity, then just go ahead for asking the questions. Hello guys, if you have any question, then feel free to ask in the Q&A session. Hello, everyone. If you have any questions, then please feel free to ask the question. The Q&A session is all up to you. If you're just curious, then let me know. I'll give you the answers. Hello, Miss Simran, you can use the chat box to write the question. So our first question, how does OWASP top 10 help developers and testers? Yeah, good question. Thank you, Mr. Tanish.
Yeah.
Like just understand like developers and testers and the like how does it help in the OWASP? Like before when we are using like developing the any kind of application, so what like if we are building from the scratch, taking the code, mostly the see in the start sometimes the developer forgot the uh, to enable stack trace disclosure, and also the to open stack trace disclosure is open while doing the means developing it may forget, and sometimes it may like the you have heard I have explained you about the error handling. So in that error handling, like on the whenever normal, if we change the host header attack, it shows the version, which version is the application is currently using. So basically, sometimes the OWASP top 10 list help the developer to guide, like you need to do the best secure coding practices, and you need to say, do the if you're using the CI/CD pipeline, you need to automate it in this way. So this is basically just high level overview. I'm just telling it. So whenever like whenever you are just developer is developing any kind of web application, or you can say Android application or any kind of application iOS, so there are some kind of vulnerabilities. The tester is giving the unit test for the testing, and sometimes the debug mode is on. I'm just missing that word in the previous like I'm just giving you the answer and I'm missing that word, so sorry for that. So the debug mode is on. So basically just while doing developer is developing their application just for their own sake, just for their own sake, like he thought like I will disable it, but he forgets that. But it will reveal so much information like the client IP and so much more. And whenever like even the whenever we I change the ID parameters which is showing on the URL, and it shows the sum of any other user information. So basically, this is how the tester is testing. There, they have the test case list. Web application have the different test case list. So this is it. Like, if you, I hope you clear what I need to say. So developer is just need to make in mind like, okay, this is the OWASP top 10. I need to make in mind like I need to build the application from the scratch and make the secure, make the my application secure. And sometimes whenever you see on the network tab on the console panel, the application is giving from nowhere, it is giving the request, even though you have not clicked on the application, but it is giving the request. So it is a bug, and the developer don't know. So this comes in the tester phase. Tester will recognize, okay, this is it. I will give the report to the developer and tell to the team. So this is it. So hope Tanish, you find the answer valuable. Thank you. Can you give, hello, Mr. Anubhav, can you give the examples of IDOR?
So basically, Anubhav, if we say about IDOR, let's say you visit a newly built web application that is a shopping website. When you added some product in your cart, let's say it's a hanky, handkerchief, or a new laptop, or your new smartphone, maybe that Apple iPhone 17 one. So when you add that in your cart, in the URL you will see like that product ID is 1. So this should not be done. This should not be reflect here like that. Why? What happened if I in that URL product ID is equal to 1? What if I change it to 2, 3, 4? I can brute force it for n number of times. So maybe I can access some other user card. What if Mr. Anubhav has iPhone 17 in his card and his card ID is equal to 1 and he has all the payment card added on that, and I as a user, when I added a product in a card that shows the user ID is equal to 2, product ID is 2, I make my product ID to 2 to 1, then I am able to access Anubhav Sharma card. And when Anwar Sharma added their payment method, from that ID is equal to 1, I am going to order phone from Anwar Sharma ID and from Anwar Sharma payment methods, and I can get that iPhone to my address. So that is the main and currently example of IDOR, where a certain identity is reflected in the URL that is easily guessable, readable, like product ID is 2, 4, 3, 5, cart ID is equal to 1, let's say blog is equal to 1, admin is equal to true, what if I try user equal to true, what if I try false equal to true. So these are the things. So moving forward, there is a one more interesting question from Mr. Rudra Kumar. What are logging and alerting failures? Can you give us a real world scenario? So, so I'm inviting my friend Divyanshi to answer this question.
Mr. Kumar, nice question. I will give you the answer of this. So this happens when the suspicious activity aren't logged or alerts are not sent, make it hard to detect attacks. Example, 100 of failed login attempts got unnoticed. What I mean by that, like if you're giving, we give the vulnerability which is called rate limit, no rate limit. So basically, we are checking on checking like giving the 50 requests of sending the forward password, and we are not getting the alerts on the. There is a system like if you have heard of the SOC, there is a SIEM system and QRadar. These are the tools. QRadar is a tool basically which is identifying the alerting messages, generating like what the application, how the application is behaving, what are the user is there, and there are many of the rules in means tools in the market which is means capturing the every user's behavior, what he or she is doing on the application, where it is clicking, and if there is any abnormal behavior on the application, it will just come up on that idea system, and you will get notice, okay, yeah, you will the main admin who is just have the admin privilege, they'll get the notice, okay, yeah, this user is means making our application at the DOS, or you can say denial of service. It caused the denial of services. It is not the normal user who is doing this. Maybe it is an attacker. So hope you clear the answer, Mr. Rudra. Thank you. Now for the Simran Kohli, our my teammate, Satyam will
So,
take it.
so Simran, your question is regarding the new update and what kind of vulnerabilities will come under the new category. So talking about the new vulnerabilities under those, so first we will take software supply chain failure. That includes key vulnerabilities like vulnerable or outdated third-party libraries, as there is a trend of cloud API and all. So all things are, most of the things people choose third party libraries they will put in their application. So using vulnerable outdated party libraries will come under the software supply chain failure. And some unverified, tempered or malicious packages, dependency confusion attacks, typo squatting package attacks, using packages without signature verification, and sometimes using unsafe build processes, no integrity checks are there, sometimes insecure software update mechanism, untrusted code repositories or mirrors people fetch from GitHub. So lack of SBOM, software bill of materials visibility, or sometimes if we talk about container images, some poisoned container images. So, and then the second new addition is mishandling of exceptional conditions. So this is like this category covers issues caused by improper handling of errors, timeouts, crashes, and unexpected states. Key vulnerabilities. like if we talk about improper error handling, revealing the, as Divyanshi said, revealing stack traces, debug messages, and unhandling exceptions leading to crashes or unexpected behavior, and race conditions, deadlocks and infinite loops, unexpected input state failures, and resource exhaustion, where memory leaks, CPU spike, thread exhaustion, even the DOS attack, denial of service by exception abuse, improper timeout handling. So these are the examples. These are the examples and key vulnerabilities that come under these new two additions. So we have looking forward the next questions. We have question from Mr. Again. His question is his question is as mishandling of exceptional condition is a new category in the OWASP list. Can you please give an example? Mishandling of exceptional condition. Yes, again. I'm inviting my friend Divyanshi to answer it. So she's going to answer it for you, bro.
So, Mr. Again, nice question. I'll give you the answer of this. So, like every application throws an exceptional handling error. For example, in the Java, if your means there is a condition try catch. So basically, what it is doing, like if this code needs to be executed, then it will go on to the try. It's just like an if else condition, you can say. And if it is not, it will go on to the this catch message where the means the particular message is displayed, which is written by the developer. So basically, what I'm trying to say is that if the application is not behaving well, it will throw the error, which is from the like whatever the Java code is running. Sometimes if you have run the normal Java code, it will throw an error. So sometimes on the application, when the application is built and user had typed something else, instead of like in the input field it is 1 2 3 and it is typing the a like so any other special characters, and it is giving the error message which is not as according to as defined on the try catch condition. So hope you understand what I'm trying to say, Mr. Again. Thank you again. So our next question is from the Mr. Digvijay Singh.
So the next question is from Mr. Rudra. His question is, I have another question that the old category was just vulnerable components using an old library. The new A3 is software supply chain failures. What is the difference? Any example? So Rudra talking Rudra talking about the old category vulnerable components using an outdated or vulnerable library in your app. For example, you can consider using log4j 2.14 with log4shell vulnerability. So the new category is software supply chain failures, much broader. It, previously, we were talking about vulnerable components. Maybe they are outdated, but they are not vulnerable, so they are not covered on that. In the new category, it is software supply chain failures. So that is much broader. It covers everything in the entire building process, not just libraries. If we include, these are malicious packages, dependency confusion, tempered CI/CD pipelines, fake Docker images, compromised updates. All these are covered in the software supply chain failures. Previously, it was not the case. For simple example, if you ask me, a developer installs a malicious npm package with the same name as your internal package. So that's a dependency confusion, right? And it steals environment variables. In short, if I have to close this question, old category is using a vulnerable library. New category is any attack on your entire software supply chain. It is not talking about just one component. So that's, I hope my answer addresses your question to Mr. Ruthkumar. So let's see what other questions we got.
I think Mr. Digvijay Singh question left. So sorry, Mr. Digvijay. Now I will answer this question. Like your question is, what new risk introduced in the OWASP top 10 2025 would most impact modern cloud native or microservice based application and why? The biggest for this simple answer is the biggest new risk for cloud native and microservice apps is software supply chain failure, which is on fall into the A03 third category. So modern apps depends heavily on the open source libraries, containers, CI/CD pipelines, and external service. What does that even mean? Like CI/CD pipelines for the automation purpose, we use the Jenkins, and for the containers, you have heard of the Kubernetes and the Docker. They are just need to balance out the web application so that for the load balancing, we are just using the containers. So these are the some new tools which is more modern apps depends. So if any part of this chain is compromised, like a malicious package, a tampered Docker image, or a poisoned CI/CD steps, the attacker can get into every microservice at once. So this is the short answer of your question. Hope it is clear, Mr. Digvijay. Thank you.
So any of my friend here do have any question regarding OWASP top 10 or anything, they can freely ask it in the chat bot. In the chat box they can write their questions. Hello guys, everyone. Thank you for joining this session. I hope this session will be helpful for you to understand the OWASP top 10 and their impact on the web application, and not about the web application, about all the stakeholders that are involved in making the web application and using the web application. If we include client side, server side, a user, a developer, any organization, even all the organization. So this OWASP top 10, maybe it's a release candidate. Vulnerabilities ranking will change in the final update, maybe or may not be, but it still shows us that we need to update our methods, categories, and every approach towards dealing with these applications and these modern world integration and all. So it's like we should always aware and update ourselves. OWASP top 10 is not a baseline that yes, I followed OWASP top 10. Now I am completely secure. OWASP top 10 is a research based, community based, scholars based that give you a baseline from where you can build yourself. Security, no system is completely secure. Every day we have to work towards their security. So OWASP token is a helping guide that can help help you to secure your environment. So I think I can close the session. So me and my friend Divyanshi, we are thankful to our audience, thankful to our Ishana ma'am for introducing us, and thanks to Cyber Sasi for uh, giving this opportunity to share this OWASP top 10 to our audience, to our users. So
Thank you everyone for joining this session. I'm ending up this event. Hope everyone has enjoyed it. So thank you. See ya. Bye bye.
So we are closing this session. Thank you everyone for being here and being part of this webinar. We are grateful to host you and grateful to share our knowledge with you. Thank you everyone. Thank you.
Hello and welcome everyone. Thank you so much for joining us today. We're thrilled to have you here for our webinar on OWASP Top 10 2025, Understanding and Mitigating Modern Web Application Risks. My name is Ishana Dubey and I'll be your host for today's session. Before we dive in, let me give you a brief overview of what we'll cover in today's webinar. Introduction to OWASP, what it is and why it's trusted globally. OWASP Top 10 Overviews understanding the 2025 release candidate, deep diving into key categories like broken access control, software supply chain failures, and mishandling of exceptional conditions. Comparing 2021 module versus 2025 module, like what's new, removed, or consolidated. Practical implementation, such as applying OWASP into top 10 in your organization. We are honored to have Satyam and Divyanshi with us today. We are excited to hear their insights on this topic. Before we get started, a few quick housekeeping items. Please ensure your audio is muted during the presentation to minimize the background noise. We'll have a Q&A session in the end of the webinar, but also feel free to submit your questions to the chat box at any time. We'll address as many as we can. We encourage you to engage with us throughout the webinar. Feel free to share your thoughts and insights. Without further delay, let's get started. I am excited to turn it over to Satyam, who will lead us through today's topic. Satyam, over to you.
Thank you, ma'am. Uh, Thank you for the introduction. I am excited to be here today to talk about OWASP and its role in helping us build secure web applications. I will start by giving you an overview of OWASP and its ecosystem, and then my friend Divyanshi will take over to dive deeper into the top 10 security risks and how we can protect against them. So, moving forward, let's start with an introduction to OWASP and why it's so important in today's web security landscape. OWASP stands for Open Web Application Security Project. It's a global non-profit organization dedicated to making software security better for everyone. What makes OWASP so valuable is that everything they create, whether it's guidelines, tools, resources, is completely free and open and also community driven. Experts from all over the world contribute, which means the guidance is practical and reliable and also unbiased. Because of this, organizations, developers, and even government regulators often rely on OWASP as a trusted foundation for web security best practices. In short, OWASP helps us understand the biggest security risks in modern web applications and provides the tools, knowledges to protect against them effectively. Today, I will be talking about the OWASP Top 10, which highlights the most critical security risks for web applications. Understanding these is a crucial step in building secure software and keeping users safe. Now that we understand what OWASP is and why it matters, let's take a closer look at the OWASP ecosystem and the projects beyond the top 10. Most people know OWASP because of the top 10 list, but OWASP actually is a much bigger ecosystem. They maintain projects that cover every major area of application security, from APIs and mobile applications to cloud native environments, machine learning models, and even AI driven applications like LLM, ML. Each top 10 list is based on thousands of real world security incidents. So it is not just theory. The goal is to provide simple, actionable categories that help the community to understand what attackers are doing today. This FIRE ecosystem allows organizations to take a holistic approach to security, protecting not just websites. It's not just about the websites, but all the platforms and technologies they build on. With that foundation, let's see what's new in the OWASP top 10 for Web 2025, which reflects the latest trend and risk. Before that, in my screen, you can see OWASP top 10 for web application that depicts the top 10 reports for web application in the OWASP. And there is a mobile application OWASP top 10, and even for API that focus on the most common and impactful security risk in API driven applications. And also OWASP top 10 for LLM that spotlights the main security and misuse threats in large language models. and AI applications. The last one, not the last one, but the one that we mentioned, OWASP Top 10 for ML, that identifies the key risks and attack vectors in machine learning and system and models. So moving forward, I am going to handle over to my friend Divyanshi here to discuss about the OWASP Top 10 Web 2025. So
Thank you, Satyam. Hello, everybody. This is Saityavanshi. Now let's move into the core topic, which is OWASP Top 10 Web Application 2025. It is the release candidate stage. What does that mean? Like it is the version, like nearly final version on global data, community feedback, and threat research. This update reflects how the modern web landscape has evolved, especially with cloud native application, supply chain dependencies, and more complex architecture. Let me walk you through the top 10 categories in the 2025 list. First one, broken access control. Second, security misconfiguration. Our third category is software supply chain failures. It is the new category which is added in the OWASP top 10. Fourth one, cryptographic failures. And our fifth one is injection. Sixth, insecure design. Seventh one is the authentication failure. It is the rename. This category is renamed in the OWASP list. Eighth one is software or data integrity failures. Ninth one, logging and alerting failures. It is also renamed. Our last is 10th, mishandling of exceptional condition. This category is also new. So this is the short overview of the OWASP top 10. Now let's move ahead and deep dive into the each category of the OWASP top 10. That's one. Broken access control. So this is the like it is the still at the top, this broken access control. So it is holding the position 1 in the 2025 OWASP top 10 list. So despite year of awareness, broken access control remains the most exploited category in real world attacks. This happens when a user is able to perform actions outside their intended permissions, essentially breaking the rules that defines when should and shouldn't allowed to do. So in 2025 edition, OWASP also has merged the SSRF category, recognizing that many SSRF flaws system from improper access restriction at the server or the resource level. So some typical issues under broken access control include like role or privilege enforcement flaws, which means like when user can escalate permission simply by manipulating the request. Our second one is the IDOR, insecure direct object reference. It is the full form of that IDOR, where sensitive data becomes the accessible just by modifying URL or the parameter which is present in the URL. So next is, and as mentioned, like SSRF is now a part of this group because of an internal resource is allowed to accept external calls. That's fundamentally an access control weakness. The impact of broken access control is extremely severe. It ranges from